Chapter 2, make sure at the beginning your notes at the top of the page, start this on a new page, new chapter. We're going to talk about linear equations and functions. Yes.
Was 170 the last section in that chapter?
Yes. 2.1 is relations and functions. So there's two things we're talking about today. We're going to first define a relation. And a relation is any pairing of numbers. If I have an x and a y and a group of them paired together, that's a relation. Some different ways that you can represent a relation. You can show it in a table. So this is an example of a relation. The domain is also called the input values, or a lot of times we call them the x values. The range are the output values, or what we often call the y values. Okay, so in this particular pairing of numbers, I have negative 2 is paired with 2, negative 2 is also paired with negative 2, 0 is paired with 1, and 3 is paired with 1. Now, I can write that as ordered pairs and put them in a graph. So, if I'm going to do, and when you do your graphs today, I will give you graph paper, and I want you to do your graphs on graph paper. When you draw your graph, use your straight edge. Make nice straight lines. Label your x-axis. Label your y-axis. And then you're going to label each of your points. So we have the point negative 2, 2. So I'm going to go negative 2, 2, and label it. I have the point negative 2, negative 2. So negative 2, negative 2. I have the point 0, 1. I have the point 3, 1.
We can label them like we did last year.
Yes, we do. Label, 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 or they will be wrong.
Repetitive sub is shown ought to be good too.
Label, label, label. This is, do you remember the thing about grammar?
Labels are.
That's part of it.
So just label the.
If you label just the points for what we're doing today, that will be added. And the axes, x and y axes. Okay? So you can represent a pairing of numbers in a table, in a graph, in a mapping. Now when you do a mapping, you look at the domain and you see there's actually only 3 numbers in the domain. The negative 2 is written twice, so you only write it once in the domain. So you have negative 2, 0, and 3. And then in this one, you see there's again 3 numbers in the range. And we have 2, negative 2, and 1. Now, I'm going to put them in order. I'm going to have 1. Oops, and the smallest one is not 1. It's negative 2. So I'm going to put negative 2 first, 1, and 2. Okay? You don't absolutely have to put them in that order. It's still a mapping the other way. But when you look at your key and look at your answers, that's what it's going to be like. Okay? So now I look at the way it was mapped, and I put arrows. From negative 2 maps to 2. Negative 2 also maps to negative 2. 0 maps to 1. And 3 maps to 1.
Wait, I'm confused.
How come we have to do that? What's the fun?
Okay, the mapping, and I will show you how to use it in just a minute when we talk about a function. Because when we talk about a function, we're interested in how many outputs there is for any one input, and that's an easy way to look at it and tell. Okay?
Oh.
Now, the other way you can do these is just a list of ordered pairs. You could say I have a list of negative 2, 2, negative 2, negative 2, 0, 1, and 3,
Wait a
1.
minute. On our homework, we have to do all 4 of those?
On some of them,
No,
okay?
And they're all left.
Questions about any of those? They do take a little time, but I don't think they should be hard, right? Do the details, label things the way they should be. Okay, one. The second thing I want to talk about today, a function is a relation, but it's a special relation. It's a relation in which each input has exactly one output. So I'm going to look at a couple of examples here. So if I have in my domain, for my first relation, I have negative 3, negative 1, 2, and 4. My output numbers, I have 2, 3, and negative 4. And here's how they're mapped. 3 maps to 2, 1 maps to, negative 1 maps to 3, 2 maps to negative 4, and 4 also maps to negative 4. This is an example. I made them up. Okay, this is what you'll be given. Riley, that's a good question. Be quiet. Okay? These aren't, yeah, this isn't something that this is what's going to be given to you. So this is what's given to you, and you look at it and you say, for every input, remember this is the x values of the input, this is the output. Is there one output? So you look at your map and you say one going from here, one from here, one from here, one from here. The answer is yes, it is a function. Now, in your assignment, for some of the problems, it says, is it a function or not? And then it says explain. When it says explain, here's what you're going to say. If the answer is yes, each input has exactly one output. Write the definition. If the answer is no, then you'll say at least one input has more than one output. Okay? Or doesn't have an output.
So what's it look like if it's not a function?
That's what we're doing next. Okay, let's look at another example.
I'm not doing myself right now.
We draw.
Okay? Guys?
Oh, so there's 3 on the x side?
Okay? Okay, this is an example of one that would not be a function, because when I look down the x column, I say, okay, negative 2 matches with one output, but 1 matches with 2 different outputs. So this is no, not a function, because 1 has 2 outputs. The number 1 has 2 outputs.
No. Wait a minute. So if there's more on the other side than.
Not necessarily. You have to look at the arrows. So look on the x value and see if any one of them has more than one arrow. That'll do it. Okay, then if it has more than one arrow, it's not a function.
One has more than one arrow. Well, she scribbled that cursor on there, and it's still with it.
Be nice to Paul.
Folks, short periods, we got stuff to do. Be quiet. Okay, now I'm going to list these in ordered pairs. I've got negative 3, 2. I've got negative 1, 3. I've got 2, negative 4. And I've got 4, negative 4. Now, from a list to tell if it's a function or not. If you look at all the x values and they only happen one time, it's a function. Okay? Let's look at the list on the other side here. I've got negative 2, negative 4, 1, negative 1, 1, 2, and 4, 3. When you look at this list, you look down the X values and you see the number 1 happens twice. It's not a function then. So you should be able to tell from a mapping, you should be able to tell from a list. You should be able to tell from a graph, and there's a special way to do it in a graph. So we're going to graph both of these and look at that. So you have your coordinate grid, label your x-axis and your y-axis, and then if you plot your points, let's see, 1, 2, 3, -1, 3, 2, 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so those are those points. Let's do the same thing with this other one, and then I'm going to compare them. So I've got -2, -4. I've got 1, -1. I've got 1, 2. I've got 1, 2, 3, 4. 1, 2, 3. Okay. So I've got them graphed. Now, here's how this works. We have what's called a vertical line test. And if I take a vertical line and I put it through any one of my points, it goes through that point and no other one. Goes through that point and no other one. Okay, that point and no other point. That point and no other point. If that happens, anytime, any place that you can draw a vertical line, it only goes through one point, it's a function. Now, let's look over here on the one we know is not a function. First point, that works fine. The second point here, if I go through 1, -1, it also goes through 1, 2. It fails the vertical line test. Therefore, it is not a function. Okay? One more with the vertical line test. And then I'll let you guys work on it. Okay? Now, sometimes we don't have just points. Sometimes we have a graph. Oh, yeah. That looks better. Okay, sometimes we have a graph of a function or a relation, and we have it look something like this. With the vertical line test, if I draw a vertical line and I run it along here, and any place I put it, it intersects only one point on the graph, it is a function. Now, on the other hand, if I have a graph that looks like this, when I draw my vertical line, it intersects my graph at 2 points, not a function. Okay?
So there's 2 different ones.
Then if it intersects it at anything more than 1, it's not a function. Okay, that is it for notes today. You're going to do, on page 76, 3 through 23. On those first ones, you've got 3 different things that you are representing. I'm going to pass out graph paper. You can do your whole assignment on this graph paper if you want. But your graphs all have to be
How many graphs are there?
on the graph paper.
1, 2,
First section, all these graphs. And do not put more than one problem on a graph. 1101. So you got some time to work.
Yeah,